Hey everybody, it's Miss Williams, and this is the last video before spring break. So get out a piece of paper and get ready to take some notes. Alright, so what we're going to talk about today is the normal distribution and the 68, 95, 99.7 rule. This is Stats Day 2. So, the question you all like to ask me all the time is, why do we need this? Well, we need normal distribution because normal helps us figure out what is typical. Alright? For example, if we had a question that said if the average woman is 5 feet 4 inches tall, or 64 inches, what would you expect to see many women who are around this height? Okay? Is it common to see women who are 6 feet tall? Is it common to see women who are 4 feet tall? So what we're going to have to do is draw a normal distribution curve. So the first thing you have to know about the normal distribution curve is that the mean is a very important part of that, and the mean is the average, and it's the center. Here we're going to use 64 because the average height of a woman is 64 inches. It's located in the middle of our curve. The next important thing you need to know is standard deviation. Standard deviation tells us how spread out the distribution is. Now, if you look at your number line that's drawn down here, this is the, it's counting by 3, so your distribution is 3, your standard deviation is 3. Alright? So, now I'm going to talk about drawing this curve. You should draw this curve on your paper. And what you're going to do is draw the lines that connect 61 and 67. Why are these important? Because it is a rule that 68% of your data will fall within one standard deviation of the mean. That means 68% of women's heights are between 61 and 67 inches. Now, if you go out 2 standard deviations away from the mean, you will encounter 95% of your data in a normal distribution. These numbers are always the same, 68, 95, and then the next number we're about to do. So draw 2 lines going up from 58 and 70, and connect those lines and make that 95%. Finally, within 3 standard deviations away from the mean, you will be able to find 99.7% of your data, as long as your data follows a normal distribution. Knowing these percentages, we can make predictions as to how much of your data set will fall between 2 numbers. Alright, so you have to remember that you have to have the mean and the standard deviation in order to draw a normal distribution curve. So if I gave you the following information, could you draw a normal distribution curve? If the mean was 30 points and the standard deviation on a quiz was 5 points, can you draw a normal distribution with that data? So you're going to start with your normal distribution curve, and in the very center goes 30. And then because the standard deviation was 5, you're going to count by 5s up and down. This is just a number line on the bottom. And standard deviation tells you what to count by. In the middle is your mean, so that's 30. And then on each side of the mean, one standard deviation above and below is 68% of your data, which means 34% of your data will be on the left side and 34 on the right side. You just do 68 divided by 2. Next, we know that 95% of our data falls within 2 standard deviations of the mean. So we're going to go up to 20 and 40 and connect those, and that makes 95% of our data. Now, if I know that 68 is in the middle, how much would these little sections be? Well, I could just merely do 95 divided by 68 and divided by 2, and I get 13.5. It's each of those half sections. If you were to add all those up, you'd end up with 95. The next is 99.7. So that connects 15 to 45. And how much would be in those little sections? Well, 2.35%. And I can get that by subtracting and dividing by 2 again. Okay? So let's practice. Suppose that the average height of boys in McGavick is 66 inches with a standard deviation of 4.5 inches. Can you draw the curve? there it is. In the middle is our 66, and you count up and down by 4.5 inches each way. Alright? Make sure you go ahead and draw the lines on there for the 68, 99, excuse me, 68, 95, and 99.7 lines. So, could you answer, how tall is someone that is 2 standard deviations above the mean? Well, if the mean is 66, 2 standard deviations above the mean would be 75 inches. What percent of boys are between 61.5 and 70.5 inches? So it looks like 61 and 70.5 are both 1 standard deviation above and below the mean. So we know that answer would be 68%. How many standard deviations above the mean is someone who is 79.5 inches tall? Well, if 66 is our middle, 1 standard deviation, 2 standard deviations, 3 standard deviations away from the mean is how big 79.5 inches is. Alright, last question. What percent of the boys are between 57 and 70.5 inches tall? So, we know that between 61.5 and 70.5, we know that is 68%, but we need that extra little bit between 57 and 61.5, and if you go back to your other curve where we broke it down, you would see that it is another 13.5%, so the total would be 81.5. Alright, we're going to work some more practice problems on these in class, and I will see you later.